Okay, so welcome members. Today we are going to see how we handle more questions about that sketching. Now, for example, some questions are going to be directing you on what to do. You don't need to follow all the steps. Now, for example, this one, show that y equaling this does not lie in the region. This for real values of x and y. Hence, find turning points and sketch the curve. Now, if we look about these regions, it means that they are talking about region of restriction. And region of restriction, the curve is not passing there because we assume that already the discriminant is less than 0. If it's less than 0, it means that those are going to be complex values. And because these are real values, y can pass where they are complex values. So, do this now. We always, because these are coefficients in the quadratic equation. So, now we form this x we form a quadratic in terms of x by cross multiplying. So if I cross multiply there, so that we having, from there I have y x squared minus 2y x equal to this side x squared minus 2x minus 3. I bring everything this side, I have y x squared minus x squared, then this will be now plus 2x, then this minus 2yx, then plus 3 equals 0. So it's that this is common, y into 1, x squared plus, it's that x is common here, I move it as 2 minus 2y into x, then plus 3 equals 0. From here, if I compare with x squared, bx plus c equals 0, and I substitute my equation here. You see my e. If we expand this, we have so if we simplify that, and instead we can divide through by 4. If we divide through by 4, we have y squared minus 5y plus 4 less than 0, which we can easily factorize into less than 0. From here, you get what we call the critical values. If I get the critical values, I put this to 0, I put this to 0, I get y is equal to 1. If I put this to 0, I get y equal to 4. Then we analyze that. You do the analysis table. You have the value of y here. Because this is in y. Then we analyze in y minus 1. Y minus 3. Analyzing this inequality there. Then y below 1. Between 1 and 4. Then y above 4. So, below 1, if you have inequality below 1, there is 0. If you have 1 and 4, there is 0, then 1, 2, 3, then 5. So, these are the ones I'm constantly. So, below 1, there is 0. If I put here 0, I have negative 1 times negative 4, which will give me a positive 4. So, I'm interested in the sign. Between 1 and 4, there is a 2. If I put 2 here, I have a positive 1. Here I have negative 2, which will give me negative 2, which will be negative. I'm interested in the sign of this. The sign of this. Above for the 5, if I put here 5, I'll get a positive times a positive, which will give me the positive. But I say, the region of restriction, it should be the one which is negative from here. The one which is negative. You follow up the inequalities. The one which is negative is the region of restriction, and so it's 1. Now my region where y doesn't pass, doesn't lie, is 1 and 4, between 1 and 4, as the question is correct. Now, from the region of restriction, you can always reduce the turning points. How? So, because I think that's the word is hence. Whenever you hear the word hence, where I will stop is where I continue from. Now, in the hence part, You see that my below section was white. So orange, you don't need now to get the y dx here. You can easily get the turning points from this. Orange, this one, the one which is below, is going to give you the maximum. And the one which is above is going to give you orange the minimum point. How? These are values of y. To get the points now, when y is equal to 1, this one, when y is equal to 1. Now I substitute my curve here. So my curve is here, which is 1 is equal to 2. When they expand this, we got over x squared minus 2x. When I cross multiply, so that I have now x squared minus 2x equal to x squared minus 2x minus 3. So you see that these are cancelled, we have 0 equal to negative 3, and it's not possible. So because this y was going to give us a maximum, you say now no maximum. Why? Because 0 can't be equal to a negative 3. Now, to get the minimum, you say when y is equal to 4, what will you be having? Now we put, where there is y, we put 4 equal to now. Cross multiply we have now here. But if I cross multiply, I have 4x squared minus 8x equal to x squared minus 2x minus 3. When I bring everything this side I have now. When I bring this side, I have 3x squared. When I bring this side, I have now minus 6x. When I bring this side, I have plus 3 equal to 0. Divide by 3, we have x squared minus 2x plus 1 equal to 0. And you see this is the same as x minus 1 squared equal to 0. So our x is 1. So we have y, we have x. So this point 1, 4 is going to be the minimum. You don't need to use you don't need to use the table now, because orange, this one is going to give you the maximum. The upper value on this one is going to give you the minimum. So this one the is the minimum. This one they never had. If you have the value also here, this point will be the maximum. You don't need to use the table. Now, and this sketch, of course, to sketch the curve, you need the intercept. So here, that one is not asked, but of course, you sketch, you need the intercept. So, you come and say my intercepts. Intercepts. When x is 0, you see that we'll be having, so that we have negative 3, up which will be having negative 3, y we have negative 3, over, down we have negative 2. We have negative 8. And down we have a 0. Down we have a 0, and so this will give us an infinity. So it's from here, we have no y-axis intercept. So this curve is going to pass in the intercept. So why? Because we are having an infinite up. So we get now, when y is 0, we have 0 equal to x plus 1 into x minus 3, the whole over x into x minus 2. If I cross multiply, that now my x plus 1 into x minus 3 is equal to 0. So either my x is negative 1 or my x is 3. The points now, is that the will be having negative 1, 0, or my 3, 0. Now, I also come and I get, of course, I need my asymptotes. So I come and I get my the vertical asymptotes, the vertical asymptotes. We said to get the vertical asymptotes, we just equate the denominator. We equate the denominator to 0 to get the vertical asymptotes. So, x minus 2 is the denominator. To get the vertical, you equate the denominator to 0. Start from there. My x is 0 or my x is 2. These are the vertical asymptotes. Then, because we say that it's having horizontal asymptote, if the power, there is power in the numerator is less or equal, there we have always horizontal asymptotes. If it's strictly greater, that's when we have sliding asymptotes, or what we call oblique asymptotes. So it's like this one, because this one, the s power is going to be x, is going to be 2, and then also the s power is 2, so it's going to give us horizontal. So expanding it, horizontal asymptotes, expanding that is that y is equal to x squared minus 2x minus 3 over x squared minus 2x. We say to get the horizontal asymptote, we divide it by x to the highest power. So that x to the highest power is this, we divide it through up and down. So that now we'll see, we divide here by x squared, we get 1 minus 2 over x minus 3 over x squared over here by x squared, I have 1 minus 2 over x. Now we say as x tends to plus or minus infinity, our y will tend to what? Now if I put here infinity, something big divided by something small, you get to 0. So I'll be having now 1 minus, this will be 0, minus 0 over 1 minus 0. So that y will be turned into 1. 1 divided by 1 will be 1. Why? Because something small divided by something big, the value you'll be getting will be approximating. So that's why where there is infinity over 2 over infinity is always approximating at 0. That's why where there is this, I put 0, even here I put 0. So now, what we are meaning to get is the analysis table. So analysis, to get the behavior. Analysis. To get our analysis members, now we get the critical values. Critical values. How do you get the critical values? We equate both the denominator and the numerator to 0 of y, the analysis of y. So now, we equate this to 0. When we equate this to 0, we get x equal to negative 1. When we equate this to 0, we get x equal to 2 and 3. When this to 0, we get x equal to 0 and x equal to 2 and 2. So to get critical values, we always equate the numerator and denominator to 0. So from there, we arrange them from big to small, then we analyze them like this. Now here, we want the behavior analysis of y. So this is going to be x here, analyzing y. So from big to small, x below, negative 1, between negative 1 and 0. Then, because from negative 1 will come to 0, then from 0 will come to 2. So between 0 and 2. Then from 2 come to 3. Between 2 and 3. Then above a 3. Below negative 1, you see that below negative 1 you have a negative 2. When you put here negative 2, you have a positive. So up you have a positive, when you put a negative 2, you have also a positive. Positive, you have a positive. Between negative 1 and 0, so between negative 1, if I have negative 1 and 0, there is negative 0.5. If I put here negative 0.5, you start me having here positive, here me having negative, so up I have a negative. Then down I have negative. This will be also a negative to give me a positive. So negative, positive, I'll be having a negative. Between 0 and 2, there is 1. When I put here 1, I have 2. This will be negative. So negative times positive times negative, I get negative. So when I put here 1, I have a negative also down. So this will be now a negative. So negative, negative to give me a positive. So between 2 and 3, we have 2.5. When you put here 2.5, this will be positive, this will be negative. So up I have a negative. This will be positive. So up, down I have a positive. So negative, positive, I get a negative. Then about 3 we have 4. I think we'll be having a positive. Now members, there we are going to see how we sketch after having everything. Now I'm going to put in the, I'm going to pause the video and I put in this part. Okay, so members, after cleaning, now I'm going to sketch the curve. The last step is to sketch the curve. We start by sketching the region. The region was from 1 to 4. So the line passing through. Anything on the curve should be drawn using dotted lines except the curve. The rest are dotted. So this is y equaling to 4. Then I have y equaling to 1. Like this. And they are telling me that the curve is not passing between 1 and 4. Between 1 and 4, the curve is not passing there, so we shade it. It's not passing here. Our curve is not passing in this region, like this. Then I come to asymptotes. I have x is equal to 0. X is equal to 0 is here. So because it's not, you go now just close to that. We said anything different from that, but the lines. And x equaling to 2, the line passing through 2. These are the asymptotes. And you name them x equaling to 2, x equaling 0. Then we also have another asymptote, y equaling to 1. Y equaling to 1 is this one, it's already there, so we name it that y is equaling to 1. So it's another asymptote. Then intercepts we had, never had x-axis intercept, but we had negative 1, 0. We had it here, negative 1, 0. Then we also add 3, 0. It's also an intercept there. Then we had the turning point as 1, 4 as 1, 4 is here. We saw 1, 4. You indicate that it's what? Minima. So that 1, 4 was minima. You indicate it like that was minima. Now, this table means when I have this, you know that above this, there are always positive values of y, and below it, a negative value of y. If this is the x-axis, the values below the x-axis are negative values of y, and the values above the x-axis are positive values of y. That's how we interpret this table. We are now the y. When I say y is positive, it means I'm above the x-axis. When I say it's negative, I'm on the y-axis. Now, we sketch a curve from asymptote to asymptote, and a curve can never cross a vertical asymptote. It can never, but it can cross a horizontal, but only once. So now we start. Below negative 1, we say our negative 1 is here. Below it, the curve is in the positive. Start in the positive. A positive will mean above the x-axis. So these are positive values of y. But these are negative value of y below, upper positive. So, because from asymptote to this point, this is, you start x-axis is here, above it is the y will be positive. So I come like this. Then, between negative 1 and 0, between negative 1 and 0, it's in the negative. Negative meaning below x-axis. And this is the x-axis, below it is the negative. But because this is an asymptote, it raises, it can never touch it, so it comes slowly, it can never touch that asymptote because x equal to 0 is an asymptote. Now, between 0 and 2 it's in the positive. Positive will mean above the x-axis for y, so it's in the positive between 0 and 2, between 0 and 2, asymptote to asymptote. That's how we sketch the curve. It comes there, now it comes there, now it touches the minimum. Then it goes above like that. It can't go this side below this because it cannot pass here because this is no restriction. The curve doesn't pass from there. So even this allow me to use the blue chalk on it like this. The curve is not passing there. Then we say between 2 and 3 is the negative. Between this is R2 and 3 is the negative. Negative will mean the negative values of y down. So between 2 and 3 is the negative, it will come because it passes here, it will also have a intercept there. Then you see it's going in the negative. It raises this asymptote, it can never touch a vertical. Then above 3 is in the positive. Above 3 means up the x-axis, it's in the positive. See that this one above the positive. So that now, there are things to note that if the curve is in the positive, it can't be up. If it's in the positive, it can't be down. So a curve can never lie in regions. When it's this side is empty. In this region it's up, this side is empty. In this region it's down, this side is empty. So that's how you look at sketching. I wish you the best.